Okay, just going to spend a few minutes going through a few of the standard nuclear decay equations, and just making sure that we are happy with the more sophisticated A-level idea of what's going on. Now at GCSE beta decay, students were told and they believed that a neutron turned into a proton plus a little electron. Okay, and they were happy with that, and that makes sense because we see the electron popping out, we know the proton number goes up by 1, we know that the atomic mass stays the same, so that in effect, they get that with the idea of conservation of mass and charge. However, we are going to take it a step further. We're going to look at charge, which is going to be our first conservation law. We are going to look at conservation of baryon number, and we're going to look at conservation of lepton number. Now I know we could look at strangeness, but the decays we're looking at won't consider that, and it's not actually part of the syllabus, so we don't need to worry about it too much. It's just we do it for fun in class. So charge, first of all, well I know that 0 is going to equal charge of a proton is 1, charge of an electron is plus minus 1, well okay, that works out. Baryon number, so that's the second one. Baryon number, I have 1 baryon. Remember the neutron is a baryon because each quark has a baryon number of plus a third of its normal matter. 3 baryons, 3 quarks in here, therefore baryon number of 1 equals 1 plus, well the electron is not a baryon, therefore it's got 0 baryon number, tick. 3, lepton number, well there's no leptons over here, remember leptons, electrons and neutrinos, equals, well 0, that is a standard matter baryon, therefore it's plus 1. Right, doesn't work. Problem. Now I know whatever it is, something's been created as well. It has a lepton number, it must have a lepton number of minus 1. Must. It has, so it's an anti-lepton. What else do I know about it? Well, baryon number is irrelevant, so the lepton number is minus 1 and it has no charge. Well, there's only one type of lepton that has no charge, and I need an anti one of those. So what we're going to be getting here as well that we don't ever see, or we don't ever see at GCSE and we don't know about, unless you watch film 2012, I think they feature in that. We have, oops, almost forgot it, an anti-neutrino. Now this would be an anti-electron neutrino most probably because an electron's made here and that's how it goes. Okay, so that's beta decay. If we have a look really quickly now, so I realise I don't want this to take too long. Beta plus decay, well in this case we get a proton, turns into a neutron, plus a positron. Now positron, remember, is just an anti-electron. Sometimes written like that, E plus, okay, equally E bar is fine as well. Well, what do I know? Charge, I know charge is going to be fine. It's, so the first one I get 0, 1 equals 0 plus 1, tick. 2, the baryon number, 1 equals 1 plus 0, tick. Lepton number, surprise, surprise, but it caught us out last time, so probably do it again. 0 plus 0, an anti-electron, therefore plus minus 1. Well, I know what must be missing then is a plus 1. It has no charge. It must be a neutrino, most likely, an electron neutrino.